Hi there, this is Mrs. B. You will need your math notebook out right now, a pencil, and possibly a multiplication chart handy. So grab those if you don't already have them. All right, so our first problem for our warm-up is what is 100% of 180? So you want to think 100% is all of it, that's everything. So that would equal 180. That's everything. Think about if you got 100% on your test. What is 50% of 80? So you're going to cut 180 in half. So that's 90. What is 25% of 180? Well, we're going to use what we know about 50%. If 50% is 90, half of 50 is 25, half of 90 is 45. Now, for 10% of 180, it's like you're dividing by 10. And when you divide by 10, remember all whole numbers have an invisible decimal point after the last number. And when you divide by 10, all it does is it slides that decimal point over one spot. So 10% would be 18. For these next slides, I just want you to turn in your notebook to your last night's homework, and I just want you to check your answers. So it'd be 276 students. The hint was, if you got this wrong, is to use 10% to help you figure out 30%. So if you're looking at 920, 10% would equal 92, right? You're moving the decimal over. And to get to 30%, you would need 3 of those. Whoops, not 99, 92. And if you add those up, you get 30%. And if you add these up, you get 276. All right, here are the answers to this one. If you need to pause during this video at any time, you can pause when you're looking at something or checking something or trying to do the work, and then you can unpause and continue. For this one, you're using that percent ruler like we did on Wednesday. So for this one, they just give you some ideas of what you might have said or how you might have grouped things together. So you may have noticed that some of the fractions had a common denominator, so those are easy to add. Others had denominators that could be easily changed in order to get common denominators. And then what does 2 out of 2 equal? So, noticing that equals 1 would make that easy to add to anything, because adding 1 to anything is just 1 more. This one, there's a lot of different ways you could have done this. Some kids do know how to do standard algorithm with multiplying, and you do it with decimals the same way. We pretend the decimal is not there to begin, and we do 2 times 5 is 10, drop the 0, carry the 1. 2 times 7 is 14, plus 1 is 15, drop the 5, carry the 1. 2 times the other 7 is 14, add 1, that's 15. The whole 15 goes down here because there are no more numbers. All right, so we're done with that, and we're done with the ones place. So we put a placeholder 0 down here. Now we're going to multiply the next row by this 1. We're just going to pretend it's a 1, not a 10, because we already have our 0 down here. So 1 times 5 is 5, 1 times 7 is 7, 1 times 7 is 7, and then you add them up. 0 and 0, 5 and 5 is 10, 7 plus 5 is 12, plus 1 is 13, 7, 8, 9. Then we look in the original equation, and we only have two numbers behind the decimal point, so we need two numbers behind the decimal point in the answer. The other way you could have done it is you could have broken this 12 into a 10 and a 2, and you could have done 10 times 7.75, because sometimes multiplying by 10 is a lot easier, and then you just needed two more of those. So you could have done 7.75 times 2 or 7.75 plus 2 and then added them together. However you got there is fine. All right, so how are the representations related? Connecting percents with decimals and fractions. In mathematics, there is often more than one way to express a value or an idea. For example, the statement, 3 out of 10 students who are going on the field trip have turned in their permission slips, communicates the same portion as the phrase, 30% of the students who are going on the field trip have turned in their permission slips. While 3 out of 10 and 30% might look and sound very different, they are both representations of the same portion of a whole. In this case, the whole is the entire number of students who are going on the field trip. So we talked the other day about all percents being out of 100, but they were talking about 3 out of 10. But we would just have to get a 100 on the bottom, and that's how you get your 30%. Throughout this section, you have been representing numbers in different ways. In lesson 3.1.2, for example, you used a diagram and a percent ruler to express your team's guess about the portion of the red beans in a jar. In this lesson, you will use a 100% block to create models of the size of various numbers on the 100% block. Today, you'll be investigating several ways to represent portions of wholes, including percents, fractions, and decimals. As you work, keep these questions in mind. How can I build it? Is there another way to represent this portion? And what is the whole? Okay, whenever we see a stoplight, that means that a mistake has been made and we need to figure out what the mistake is. So Susie looked at the diagram below and wrote 134% equals 134 out of 200. Is she correct? Why or why not? Well, I kind of just gave you the hint that when we see this, it's why is she not correct? Think back to Wednesday when we talked about that all percents were out of what? Hopefully you said out of 100. And hopefully you remembered me saying no matter what the percent is. So if it's 1%, it would be written like that. Or if it's a number over 100%, it would still be out of 100. But the only way we can show it on a hundreds block is to show the 34 on a second block, but we're still counting it out. This is a percent block, okay? So it's just out of this. Okay, so use the diagram of 2 out of 5 at right to make sense of the following questions. So first, we want to describe what 2 out of 5 would look like if it were built on a 100% block. What are the largest pieces you could use? How many of these pieces would it take to build the portion? What are the smallest pieces you could use? How many of these pieces would it take to build the portion? All right, so we have 2 out of 5, but now we're talking about a big hundreds grid and how we could transfer this information down here. I'm not going to draw all the lines in. I'm not going to put 100 blocks in there because that would take too long. But we know that's 2 out of 5. And we know we need to convert it to a 100 block. So we'd have to ask ourselves, does 5 go evenly into 100? Well, hopefully we know that it does, or you can check your multiplication chart to see how many times, because we need that 100 on the bottom, and then we will know how to fill out our hundreds block. All right, so 5 times 20 equals 100. Whatever you do to the bottom, you have to do to the top, because you're multiplying by one whole. So 20 out of 20 is 1. And 2 times 20 is 40. So we need 40 blocks in our 100 grid. So I can draw in some of these. 2, 3. All right, so there are 10 strips there. And we need 40. So 10, 20, 30, 40. All right, so that's how we would fill out the 100% block. And it said, what are the largest pieces we could use? Well, the largest pieces we could use are 10 blocks, right? And we would need 4 of them. What are the smallest pieces you could use? Well, we could use 40 of these, of the 1 blocks, and 10 of these. All right, so for the top problem, we actually already did it on the previous page, because it says write 2/5 as a fraction with a denominator of 10. Well, we didn't do that actually, so we would, oh my gosh, 2/5 as a fraction with the 10 on the bottom. So we would just multiply the top and the bottom, and we would have 4/10, which we saw we used 4/10 to make our 100 grid. And then we also multiplied it by 20 to get it up to 100. So we already did that. Let's go to the next one. It says, how could 2 out of 5 be written as a decimal? How is the decimal representation related to the 100% block diagram that you described in part A? All right, so we can do it 2 different ways. So we can use this 4/10, 4 out of 10. But if we say it 4/10, we can write 4/10. If we did it like from the previous page where we had 40 out of 100 or 40 hundredths, it would look like that. So that kind of answers this question too. We could call it 4/10 or we could call it 40 hundredths. All right, guess my decimal. Maya and Logan invented a new game called Guess My Decimal. One of them thinks of a decimal and gives the other a clue to solve for the mystery decimal. Logan begins the game by saying, first, I think of the 100% block as a 1 block so I can make a decimal instead of a percent. Because if you had the whole 100 block filled in for 100%, that'd be 100 out of 100, and that just equals 1 whole. Okay, so that's why he's saying 100% block can be thought of as one whole. He goes, then my decimal can be represented on the block like that. So he pointed to the diagram at right. What is Logan's decimal? If you need to pause here for a minute so that you can count that up and try to write a decimal in your math notebook, and then you can start the video up again and see if you and I come up with the same thing. All right, so if I am thinking of these as decimals instead of whole tens, this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. And I would write it like that. All right, now it's Maya's turn. She said, my decimal is equivalent to 3/5. Well, when we want to change fractions into a decimal, what we need on the bottom are either a 10 or 100 or 1,000 so that we can get tenths, hundredths, or thousandths. So we can easily change that 5 into a 10 by using our giant 1 and getting 6 out of 10 or 6/10. So her decimal is 6/10. Logan finishes the game with the following clue. My decimal can be built by combining 38 hundredths and 4 hundredths. What is Logan's decimal? All right, well, we know that if we're going to add decimals, if we want to be successful, we are going to stack them and line up the decimal point. So 8 plus 4 is 12, drop the 2, carry the 1, 3 plus 1 is 4, drop the decimal, and his decimal is 42 hundredths. Okay, so math notes, they're just telling us about how we can use our base 10 blocks for percents. So the 3 basic blocks represent 100%, a 10%, and a 1%. A percent is a way of expressing a number as a fraction out of 100. In the example shown at right, 23 out of 100 squares are shaded to represent 23%. 23% can be expressed as 23 out of 100 or 23 hundredths written as a decimal or with words, 23 hundredths. All right, it is time to do your homework. You will be doing problems 50 through 54, which is 5 problems starting on page 109. I need you to get a copy of the 100 grid paper from Mrs. Terrian if she hasn't already handed them out to you. You're not going to use all of the grids to do your homework, so don't get panicked that you have to do that many problems. And then if you need more room for some of the problems that you don't use a 100 grid for, or if they ask you for something else, you can just do it on the back of the worksheet. Just be sure to keep that worksheet safe in your math notebook to show me on Monday. I hope you have a really good weekend. Be kind to yourself and be kind to Ms. Terrian.